Okay, children, now we have to study functions next. And mind you, functions are very important, children. Okay, the whole concept of this is based on functions only. Okay, so although you're already familiar with what a function is, you have been dealing with functions, only that you did not know that we call them as functions, maybe. Okay, so as they have defined out here now in terms of sets and relations, what a function is like. Okay, so see, as they have written here, function is actually a special type of relation. Okay, certain relations. What are relations? Relations were subsets of Cartesian product of two sets. Okay, and out of those relations, certain type of relations are called functions. Now we'll study in detail which kind of relations will be termed as functions. Okay, so a relation f from a set A to set B. So by now, I hope it is clear when I say from a set A to set B, means we are considering Cartesian product of A and B. A cross B ka subset hoga again. Okay, as we are saying ki function is actually a relation only. Okay, and every relation is a subset of A cross B. So a relation F from a set A to B is said to be a function if every element of set A has one and only one image in set B. Okay, so that is peculiar about a function from relation. Okay, so that particular relation we can say which has one and only one image is termed as a function. So function is basically, children, a rule. Somewhere it must be written here. Okay, here, see, function is actually, we say, a rule in which what we do, we find there are two variables. We know we have two variables in ordered pair, say A and B. Okay, so a rule with the help of which according to A we find B. Okay, certain rule जिसकी वजह की हेल्प से हम B डिफाइन करते हैं, जो हमने इमेज बोला था. ओके, सो देयर इज दैट सेम पर्टिकुलर रूल which will be followed by B, every B of the ordered pairs present there. Okay, so that is a function. And now what more they have to say, that f let f is a function from A to B and A comma B belongs to this function, then that's the way you write a function, children. Okay, that's the way of depicting a function. That is how you write it. Okay, so f, that is rule, which we will come to know what the rule is like. And f of A is equal to B. तो हम ये image को ऐसे लिखते हैं. This means B is image of A under this particular rule. Okay, so where B is called as image of A under F and A is called its pre-image. Okay, so elements from the domain, these are termed as pre-image of B under F, right? So that was to be understood there, and that's the way we represent a function. A function from set A to B means this will be our domain A and B will be our codomain. Okay, mapping हमारी from A to B होगी. This way, ordered pair में first entry will be from set A, second entries will be picked up from set B. Okay, looking at the previous examples, we can easily, okay, they are talking about examples out here that we've studied. And they are saying that none of these examples are depicting a function. Okay, so as they are saying out here, example 7 is not a function because element 6 has no image. Then second, they are saying example 8 is also not a function because the elements of the domain are connected to more than one image. Similarly, relation 9 is also not a function, and they're asking you why. Let's get back to those examples and see and understand what a function is like. Okay, so that was your example 7 here that they are talking about. So in this example, that's the mapping. Okay, example 7 के ये mapping उसने दिखाई है. So this was a relation, but they are saying this is not a function. Why? Because डोमेन का एक एलिमेंट रह गया है जिसका हमने इमेज नहीं मिल रहा है. All right, so every element of domain should be mapped with certain element of the codomain. Only then it is a function. So there should be no left outs out here. यहाँ पे left out होगा चलता है. Codomain में we can have entries left over, but in this we should not have any leftover entry. Okay, then most importantly, that is what your definition was. अभी जब उसने function define किया है, this is what was told to you. Okay, that pre-image cannot be repeated. This is known as pre-image. All right, and it cannot be repeated, right? So see, 25 is mapped with 5 as well as with -5 here, 4 is mapped with 2 as well as with -2. So whenever two images have same pre-image, then this is not a function. This is a relation, but this is not a function. So to identify a function, what we have to focus on is that your first entry of the ordered pair. Your first entry of the ordered pair comes from domain. Okay, so the first entries should never repeat. That is what was the definition, that every pre-image will have one and only one image. It cannot have two images. Is that clear? Okay, because and then for the last one, ninth example, they were saying check if this is, see, from the ordered pair. Now this was in the form of mapping, we could see, and here in the case of ordered pair, they had said it is not a function, and they were asking you why. So what will be your reason? You would say 1 comma 3 and 1 comma 4. So you can see 1 is repeating here. So if your first entry of the ordered pair x agar aapka repeat hota hai, this is no more a function. This can be a relation but not a function. So yahan pe bhi 2 and 2 repeat ho raha hai. So 2 has two images. 2 is mapped with 3 as well as with 4. So this is not a function. Okay, so function mein ulta ho sakta hai. We can have the images can repeat. Maybe I can have 1 with 4, 2 with 4, 3 also with 4. So image repeat ho rahi hai, no problem, but pre-image repeat nahi honi chahiye. Then it's not a function. All right. So that is what was about function that they had told you here, the definition, and I hope it is quite clear now. Then next, what do we have? This definition we've considered. Now here in the examples, I think the examples are simple. You can read through them and try to follow. If there's any problem, then let me know, okay? So let n be a set of natural numbers, be a relation defined on n such that relation x comma y, y is 2 times x, x and y are natural numbers. What is the domain, codomain, range of R? And then is this relation a function? Every function is definitely a relation, okay? But every relation need not necessarily be a function. Samajh rahe ho aap? Okay, that relations are subsets of A cross B or maybe A cross A, and functions are subsets of relation. So every function is a relation, but every relation may not be a function. Only specific relations are called, termed as function. And we've talked about it, that what kind of relations can be functions. Okay. All right. So getting back to this example, I think you'll follow it. So domain is already usne clear kar diya yahan ordered pair mein x and y both belong to natural numbers. So your domain is set of natural numbers. Then your codomain is also set of natural numbers, but range is different. Okay, I hope by now it is clear difference between codomain and range. Codomain hoti hai aapka second set jiska Cartesian product hota hai A cross B. Okay, so that B is your codomain, and range is collection of images. So that is Y, collection of Y's as per this definition. So Y is equal to 2x बोल रहा है. So if x is a natural number 1 2 3 4 5 6, तो आप उसका 2 into 2 करोगे तो आपको सब even multiples मिलेंगे. 2 1s are 2, then 2 2s are 4, 2 3s are 6, 2 4s are 8. So your range, if you collect your images, all the ranges are coming as even numbers. So your range will be even numbers, and range has to be a proper subset. Not necessarily, it can also be exactly equal to codomain. At times codomain and range are equal, but need not every time be. Like in this case, it's coming, your range is coming as even numbers, even natural numbers. Okay, so that way then rest of the examples also you can go through, you will understand hopefully. Let's go to this definition. That's another important definition here, because we will be focusing on this only. We'll be studying real functions. Okay. So definition 6, as they have written here, is saying a function which has either R or, I hope you understand this, capital R, they mean real numbers, set of real numbers. Okay. A function which has either R or one of its subsets as its range is called real valued function. Okay. वैल्यू ये हमारा जैसे अभी ऊपर उसने डिफाइन किया था, ये y इज इक्वल टू 2x, तो ये वैल्यू हुई हमारी इमेजेस. ओके, x के इसके लिए क्या वैल्यू आई? इफ आई पुट x इज इक्वल टू दिस, देन व्हाट इज इट्स वैल्यू? ठीक है, तो वो आप करते हो. दैट इज व्हाट आई सेड कि फंक्शंस यू हैव बीन डीलिंग विद, आप करते आए हो, y is in terms of पूरा expression बना के फिर keeping various values of x, finding y. You've done that earlier also in your junior classes, right? Only that maybe you were not, it was not mentioned that this is termed as a function, right? So that is what they are saying, the real valued function, कि जब answer हमारा, I should say, okay, answer या image, now you know we call it as actually image, when the image comes out to be a real number. Okay, when image is a real number for whatever be the entries of domain, it is termed as real valued function. Answer हमारा real number आ रहा है. Okay, so real valued function. Further, if its domain is also real, okay, if x, all the x pre-images are also real numbers or a subset of real number, then that is called a real function. Okay, so when your x and y both are real numbers, then it is called a real function. And if your y comes out to be a real number, then it is called a real valued function. Okay. All right, examples, is sub calculations and children, which is not difficult. You'll go through yourself and hopefully you'll understand easily. Now, this children is something again important for you for your further studies, some functions and their graphs. Okay, so you need to learn and you need to know these names, various, that as soon as I say identity function, you should be able to identify, tell me what it would look like. Okay, when I say constant function, and an image should come in your mind. Okay, so these functions, their names, their graphs, you will read through and you will try to memorize, understand them, because they are really required throughout. Okay, so first they are saying is identity function. So as the name itself is making it clear, identity, you get back the same thing. Okay, so that's the way to write function. Y is some function of x. And what kind of function it is? That it is giving you x only. तो x उसका आपका, तो आपका इमेज एंड प्री इमेज सेम आया. आपने ऐसा रूल लगाया कि आपको सेम चीज वापस मिल गई है, 1,1, 2,2, 3,3, like that. Okay, so this kind of function, when y is equal to x, or y, now we know we write it as f of x. So if f of x is x itself, okay, then it is called an identity function. And mind you, we are talking about now real functions. Okay, it goes without saying that all these, when we are saying, we are considering real numbers, set of real numbers. See, they have said it will be mapped from real number to real number. Aapka x as well as y, domain, codomain, dono real numbers honge. Okay, so that is identity function. Now, when next time I say identity function, you know I'm saying y is equal to x or fx is equal to x. Right? And the graph for this automatically, जिसको थोड़ा आपको plotting आता है, तो you can understand the graph will come as this. Like when I was telling you, I said कैसे ordered pairs आएंगे? Obviously, image and pre-image same होनी है, तो 1,1, 2,2, 3,3. So this you will get a line like this: 2,2, 4,4, 6,6. Likewise, -1, -1. So you get a line which is equally inclined to the coordinate axis in the first and the third quadrant. So something like this, the graph comes. Okay, so next time when I say identity function, तो वो picture आ जानी चाहिए आपके mind में कि okay, this is how it will look like. Y is equal to x, and the graph would come out to be something like this. Next important function is your constant function. Again, as the name makes it very clear, that y, or which we call as fx now, will be equal to some constant. Means whatever be the value of x को आप कुछ भी रखो, answer, your image will come out to be the same. That would come out to be a constant thing. Okay, f1 is also 5, f2 is also 5, f3 is also 5. 5, I'm just saying for an example, it can be anything, right? Okay, so defining a function f from r to r, y is equal to fx is equal to c, x being real numbers, where c is a constant, right? So c remains constant or your y remains constant, y remains the same. So ऐसा ग्राफ आना है naturally. x के कुछ भी वैल्यू रखूं मैं, -8 रखूं, -6, -4, -2, 0, 1, 2, 3, 4, 5, anything, every time y will come out to be same. Okay, so you know, आपने line पढ़ी है, तो y is equal to some constant. This gives you a line parallel to x-axis. Okay, so that's what is your constant function, and this is what the graph will come as. Then next would be your polynomial function. Also nothing, you have been dealing with that, you know what a polynomial is. Okay, 9th में भी आप लिखते थे. This polynomial expression used to be expressed like fx. So this is only called a polynomial function. Okay, so ये जो आपका expression आया है polynomial, if you address it as some function of x and then you find the corresponding y, you have been doing that. Okay, so this is known as a polynomial function, and polynomial function में variety है because we know we can have polynomials of various degrees. So some basic ones are, the above was a linear, is you already know a linear polynomial represents a line, straight line. Then next would be quadratic, so that this kind of shape you get for a quadratic polynomial, parabolic shape. Okay, in physics you must have already studied maybe by now parabola. Okay, then if it is cubic, then the curve comes out to be something like this. So isko roughly thoda mind mein rakh lena hai apne, that's it. Okay, so that was your polynomial function. The next is your rational function. You know what a rational number is, p by q form. So if it was numbers, we call it rational number, and algebraic expression में भी आपने rational वो पढ़ा है. तो now since you know we are calling it as function, so some function of x in numerator and some other function of x in denominators, and this kind of function together would be called as a rational function. So a polynomial in numerator and a polynomial in denominator, that gives you a rational function. Okay, so there's not much here for rational. And yes, now these two are very important, children. Modulus function and signum function will be used over and over again, and you should get that picture clear in your mind. As soon as I say modulus function, you should know what I'm talking about. Okay, so modulus function, yes, also maybe you're familiar with that. This is how we take the modulus value, any number put in those vertical bars. So that is how we represent a modulus function. Now to understand it, now modulus function, what do we do in modulus function? In modulus we take positive value only, right? We, even if the number is negative, we take its positive value. That is how you know till now modulus function as that modulus value of 5 is 5. Modulus value of -5 is also 5. Okay, so हम करते क्या है modulus function में, we drop the sign or we consider only the positive value. So according to that, it has been defined like this. This is how you will define a modulus function. We'll say fx will give us x. लेते तो हम वही हैं. As I said, modulus of 5 will give you 5 only. So modulus of x would give you x if it is positive. X is greater than equal to 0 means it's a positive number. So when the number is positive, we write it as it is. Like I said, modulus of 5 is 5 only. And if it is a negative number, modulus of -5, I said is +5. So वो -5 को मैं minus से multiply कर रही हूँ, तो minus minus becomes positive. That's the concept. Okay, so when a number is negative, x is smaller than 0 means number is negative, you multiply it with another negative sign, so that negative ultimately you get a positive value. That is what the modulus is all about. Modulus value means positive number. Okay, so this is how you have to remember. How do we define modulus function? For all x greater than equal to 0, we take it as x only. And for all x smaller than 0 means negative number है, तो उसको आप minus times लोगे, so that even that becomes positive. Okay, so this definition you have to keep in mind, and the graph of that naturally, ये तो आपका first part. If you see fx is equal to x, ये identity function जैसा हो गया. अभी above we saw identity function, so identity function का graph ऐसे ही आ रहा था, equally inclined to coordinate axis in the first quadrant, right? And now when you're saying fx is equal to -x, okay, so y तो आपका positive ही रहेगा, क्योंकि आंसर जो है वो positive आना है. That is what modulus is all about. Minus minus हम उसे positive बना दे रहे हैं. ठीक है, तो x अगर negative है, this is all your negative x. For all negative values of x also, y would be positive. So it would go again equally inclined to the coordinate axis, but in the second quadrant, because second quadrant में x negative होता है and y positive होता है. So that is how your graph will come. For all negative x, it would be here, and for all positive, it would be in first quadrant. Okay. Now from the modulus function only, you come next to signum function. Okay. The signum function, I guess they have not written here. Here it is. Okay. So this is how you represent a signum function. fx is equal to modulus of x upon x. So when I say signum function, तो आप सीधे क्या लिखोगे? Modulus of x upon x. and uska elaboration agar aap karoge, if you want to write it in elaborative form, then this is how it is. Okay, and why so? That's because here अभी हमने मॉडुलस का ऑलरेडी डेफिनेशन देख लिया है कि फॉर एक्स इज पॉजिटिव, फॉर ऑल पॉजिटिव एक्स, फॉर एक्स ग्रेटर देन 0, मॉडुलस ऑफ एक्स कितना आता है? x ही आता है. तो इट विल एक्चुअली बिकम x अपॉन x. तो x अपॉन x will give you +1. And for all x smaller than 0, negative x, this will come as minus of x. मॉडुलस का यही डेफिनेशन था. तो अगर आप ये मॉडुलस की डेफिनेशन रख दो सिग्नम फंक्शन में, then this is how you break it. Okay, for all positive x, it will come as x upon x, which will become 1. And for all negative x के लिए आप इसको minus x रखोगे, तो it will be minus x upon x, which will give you -1. So that is how we expand this signum function. Okay, and obviously this is something peculiar at x is equal to 0. वो actually 0 by 0 आ रहा है. Later on you'll come to know कुछ हमारा indeterminate form होती है and all that. We'll study that in details later. So as of now, you'll just remember it. It has been defined like this. Signum function is defined to be 0 at x is equal to 0. Okay, although it won't make any sense, 0 upon 0. So that's an absurd result which you cannot calculate. Okay, so you just have to remember this is the short form of expressing it, or maybe in terms of variables, that is how you'll express. And if you expand it using definition of modulus, then this is how we expand it. A signum function is 1 for all positive x and -1 for all negative x. And hence its graph goes something like this. For all positive x, it would be x is equal to 1. So line parallel to x-axis passing through y is equal to 1. And for all negative x, this is your range for negative x. Here x is negative. It would come as -1. तो ये नीचे जाएगा. Y is equal to -1 से parallel line pass होगी. So that is what the graph will be like. Okay, and see, this you have to leave unshaded. यहाँ पे holes छोड़े हैं उसने. This is your line x is equal to 0. This is your point x is equal to 0. तो उसके लिए यहाँ पे शेडिंग की है सी उसने. x is equal to 0 पे y भी 0 था. And here you leave holes. कि this is not to be included. Okay, fine. Then next is your greatest integer function, also important here. So greatest integer function, children, you need to understand this is gives you the greatest integer value. तो इसमें आपको क्या करना होता है, जो भी नंबर होता है, रियल नंबर्स की बात कर रहे हैं, they can be decimals also. So you drop the decimal part and you consider the integer just before that decimal number. Okay, so maybe यहाँ पे they have defined. Let me see if you understand. I'll explain you with the help of an example. First, let's see how they have expressed it. Okay, so they are saying whenever a number is from -1 till less than 0, its greatest integer, that's the symbol, children, for greatest integer function. That is how we represent. fx is equal to, in rectangular bracket अगर ये x लिखा है तो आप समझ जाओगे we are talking about greatest integer function, and उसमें हमें greatest integer function में integer value लेनी होती है, decimal drop करना होता है. As they've shown you here, that whenever the number will be from -1 to less than 0, then its greatest integer value will come as -1. -1 है तो भी -1 आएगी, and अगर उससे बड़ा integer, see now this is something bit that gets confusing for children, ki when it is negative number. So what did I say? It is in greatest integer value, you have to take integer just before the given number. So when I write minus of 0.5, say minus of 0.5, तो minus of 0.5 आपका यहाँ कहीं आएगा. Say this is 0, this is -1. Minus of 0.5 will be somewhere here in between. So the integer before minus 0.5 or before half is -1. तो आपको integer पहले का लेना होता है. Okay, तो आप उसको 0 में round off नहीं करोगे. Do you get that? Positive के लिए तो it is very clear. Like if I say 0.5, तो integer before 0.5 is 0. If I say 1.5, not necessarily 5, it can be 1.9 also. 1.9, integer before 1.9 is 1. When I say maybe 2.2, integer before 1.2 is, 2.2 is 2. You're getting that? And integer before, if I say greatest integer value of 3.125, 3.125, तो उससे जस्ट पहले का इंटीजर 3 आ गया. If I say integer, greatest integer value of 4.98, तो आपको उसको राउंड ऑफ करके 5 में नहीं पहुंचाना है कि 98 से 5 पास में है. डू यू गेट दैट? इट्स नॉट अबाउट राउंडिंग ऑफ. 4.99 भी अगर मैं आपको बोलती हूँ तो उसका ग्रेटेस्ट इंटीजर वैल्यू क्या आएगा? बैक टू 4. इंटीजर आपको डेसिमल पार्ट छोड़ देना है, खाली इंटीजर पिकअप करना है. इज द पॉइंट क्लियर? ओके, सो यू नीड टू बट टेक बिट केयर फॉर नेगेटिव नंबर्स, बिकॉज अगर मैं यहाँ पे बात करती हूँ, सपोज आई एम टॉकिंग अबाउट minus of 1.7, minus of 1.7 will be somewhere here. Okay, so minus of 1.7 से पहले का इंटीजर -2 बनता है. Okay, तो पॉजिटिव नंबर्स में तो कोई इश्यू नहीं है, आप डेसिमल छोड़ दो, सीधे बस डेसिमल से पहले का इंटीजर लिख दो. बट व्हेन इट इज नेगेटिव नंबर्स, you'll have to take care, you'll have to go an integer back. Okay, so if the range is say maybe from -3, any number from -3 to less than -2, it can be -2.99 also. -2.99 भी अगर आप कह रहे हो तो वो यहाँ कहीं आएगा, and -2.01 भी अगर मैं कहूंगी तो वो भी यहीं आ जाएगा. तो दोनों का ग्रेटेस्ट इंटीजर वैल्यू क्या आएगा? -3. Okay, with examples it will become clear. You can see more examples and still you don't get it, I'll try to explain it again. Okay, but I think I've spoken enough. You must be tired of listening to me. Okay, so now next let's take algebra of real numbers, which is quite simple. But children, this is very important. Now read through all these different types of functions once again and reread them over and over again, and make sure you're very clear with them. Not difficult to understand, but yes, of course, you have to memorize them for further studies till 12th. Okay, all right, now getting back to the remaining topics out here. That was algebra of real functions. So whatever we are studying, we know we talk about its algebra, and its algebra means operations that can be done. So two real functions can be added, can be subtracted, can be multiplied, can be scalar multiplication and all that. So this won't be difficult. You have been doing it. Okay, so here what are they telling you is that if you have two real valued functions, they can be added. Okay, from this to this. So like f plus g of x is fx plus gx. So variable se or confusion hota hai, rather I would say. So when you go to examples, things will become more clear and it's not difficult. Like these are two functions given to you. So simply what are they telling you above is that if you have two real functions, like one function is squaring the number, another one is 2x plus 1. Then you can add these functions. You can also subtract them. You can also consider their quotient. You can also find their product, and you can also scalar multiply it. Okay, scalar multiplication, you understand, increasing a function a constant number of times. So I can maybe find 5 times fx, so it will become 5x squared. Okay, so this is not difficult, children. इसको आप करते आ रहे हो, only ये way of representing symbols वगैरह आपने थोड़ा देखने हैं. Okay, so children, just read through this properly, clear your concept, ask whatever queries you have, and then next I will move on to, we will discuss 2.3.